Hello my dear you all, Jai Hind. I am Rakesh Chaubey from Sunbeam Sun City. Now my dear, after the video which I have uploaded for the dimensions of different very important physical quantity, elastic, constant elasticity, constant Young's modulus, stress, strain, gravitational potential. After that video my dear, I am uploading today uses of dimensions. Now my dear, let's go for there are three uses of dimensions. And in which I am discussing today. I am sending you the video for the first use of dimension, and the first use of dimension is based on the principle, and that principle is called as principle of homogeneity. My dear, I will state this principle to whom we call, what do you mean by the principle of homogeneity? We will state this principle, and for that I have taken some examples. So first I will solve some examples. Am I clear? Which is good example, important example, standard examples. Through the example, we will get the knowledge about the principle of homogeneity. And my dear, this principle of homogeneity we are using, or this particular use for dimension, is applicable to check the correctness of a equation. Please note down this. It is used to check the correctness of equation. Here in the example, you can see I have given the equation. How I came to know that, sir, it is an equation? Whenever, my dear, there is a LHS, that is left hand side and right hand side. Am I clear? So whenever the things provided left hand side equal to right hand side type things, it is an equation. Now this equation which is given, right? This equation is whether this equation is valid or whether this equation is correct, that we have to check by principle of homogeneity. And that is the first use of dimension, my dear. So let me tell you, in the first use of dimension, we are using the principle of homogeneity. So let's begin with the first example. S is equal to ut plus half at square. Now to begin with this example, S is equal to ut plus half at square. My dear, first of all, you have to see that in the LHS and in RHS, here in LHS there is a word S, and you all know that S is a displacement. So first very important one is that you should know each and every quantity. सबसे पहला important point is you should know each and every quantity. So here S is displacement. You already know velocity into time. T is time, A is acceleration, and then all. So you all know that what is what. So my dear, you all know that here S is the displacement, U is the velocity, and T is time, A is acceleration, and further T is time. Okay. Second important thing, so first everybody should aware about the quantity which is given, because quantity are written in terms of alphabet. So you should know that this alphabet represents which quantity. That is one step. Second step, my dear, you have to see that on left hand side here in the given equation, this particular example, in left hand side there is only one term. Only one term, and that is S, that is displacement, S. But on the right hand side, my dear, you know terms are categorized, or terms can be identified with the addition sign and with the subtraction sign. So now, my dear, here on the right hand side you can see ut is one term. I repeat, ut together is one term, and half at square is the second term. It means in the given equation on left hand side there is one term, that is displacement S. But on the right hand side there is a two terms. One is ut and other is half at square. So let's begin with the dimension for this by the principle of homogeneity, and then at the end I will tell what is actually happening according to the principle of homogeneity. Now, so let's start here. Begin with this. Let the given question, I will put it as equation number 1. Whatever question is given to us, that I will put it as equation number 1. So here it is LHS, left hand side. Now I have to find the dimension of S. So I will write dimension of S. And dimension of S is a displacement. So it is L power 1, L power 0, T power 0. No doubt. Because displacement carrying only length. in magnitude, right? So L power 1 will be the dimension because S is only having power 1. Mass, there is no mass, there is no time. So I hope you understood the dimension of displacement in the equation number 1. I hope it is clear. In left hand side, I will put this as equation number 2. Am I clear? Now let's go to the right hand side. Now in the right hand side, my dear, you can see what is there on the right hand side. I will write here RHS. On the RHS side there are two terms. So number 1, the first term is UT. The first term is UT, right? So now what is the dimension for UT? This is the dimension of U multiplied by the dimension of T. This should be written this way. So now dimension of U, you all know that U is velocity. So it is L1 M0 T minus 1. This is the dimension of U multiplied by dimension of T is T power 1. So the dimension of UT will become, here I am writing the answer for UT. UT together giving me dimension as L power 1. Yes, M power 0. Okay. T power minus 1 and T power 1 will become T power 0. This is my equation number 3. I calculate the dimension of UT. Now my dear, there is another term, half AT square. You can see half AT square. But my dear, in the equation, this half is a number. In the equation, the half is a number. So here I will write, since half AT square, I will write, since half is a number, it is constant, hence dimensionless. So this is constant, it is dimensionless. Because I told you earlier in my all video that except a number, not all constants are dimensionless, but if it is a number, then numbers are dimensionless, whether it is half, whether it is 2, whether it is 1, 4, 5, 8, whatever be the number, it is dimensionless. So now half is a number, it is constant and hence dimensionless. So now the dimension, therefore, what is left out? If half is taken out, therefore, what is the term? So the term is nothing but AT square. AT square. Now the dimension of AT square, because half is eliminated, it is a number. So dimension of AT square can be written as dimension of A, that is acceleration, multiplied by dimension of T ka square. This should be written this way. Please have a method of writing. AT square में dimension of A, that is acceleration, multiplied by dimension of T. Dimension of T is T only because it is time, and then I have to do the square on that. So now let's start for the dimension of A. The dimension of acceleration is L1 M1 T minus 2, L1 M0 acceleration, L1 M0 T minus 2, and dimension of T power 2, that is T. This is dimension of T is T, and here it is square, so this will be T square. So now it will be L1 M0 minus 2, and this 2 will become 0. I hope it is clear. This is the dimension of AT square. This I will put it as equation number 4. So now you can see on the right hand side there are two terms. One is UT and other is, the second term is AT square. Half is eliminated because it is a number. Now my dear, after taking, because now nothing is left on the right hand side, I have calculated dimension of S, okay. I have calculated dimension of UT, yes. I have calculated dimension of AT square by saying this, that half is a number, it is out, it is constant, it is dimensionless. Okay, now my dear, what should I do for the next step? Next step, substituting equation 2, 3, 4 in 1. So 2 is this, 3 is this, and 4 is this. So 2 is representing dimension of S. So here it is written in equation 1 S. So what is the dimension of S? I will write here This is L1 M0 T0, because equation number 1 may S is here and dimension of S is this, I have substituted there, is equal to now UT. So substitute equation number 3. I said 2, 3, 4 in 1. So 3 में UT का dimension is given, that is L1 M0 T0. So here I will write UT के place पे L1 M0 T0. Okay. So I have written dimension for UT also. Now here it is plus. I will write plus. Now next, here this is half. I already taken half as a number which is dimensionless. So now I will no need to write here half. Why? Because sir, you are writing dimensions. We are not writing any numbers. So here I have written dimension, here I have written dimension. What I said, I have converted each quantity of the equation in terms of dimension. So this is L1 M0 T0 plus AT square dimension is also L1 M0 T0. So now my dear, what you are supposed to see, try to understand. This is left hand side dimension and this is the right hand side first term dimension. This is right hand side second term dimension. Am I clear? Please try to understand. This is left hand side term dimension, that is S ka dimension. This is right hand side first term dimension UT ka, and this is right hand side second term dimension, that is AT square ka. Why I am emphasizing so much? What is the meaning of this? Each term of the LHS and each term of the RHS, that is each term of LHS and RHS has the same dimension. L1 M0 T0, L1 M0 T0, L1 M0 T0. Every term has the same dimension. You can see, and that is the principle of homogeneity. That is the principle of homogeneity. So what is the principle of homogeneity I am writing here? According to this principle, each or every term of left hand side and right hand side, according to this principle, each or every term of LHS and RHS has same dimension. You can see the term on LHS dimension is L1 M0 T0, the term on first term on RHS L1 M0 T0, second term of RHS L1 M0 T0. So my dear, this each term possesses the same dimension. And जब ऐसा होगा, then we can say, so according to this principle, each or every term of LHS and RHS has same dimension. Hence, the given equation become dimensionally correct. I will tell this word also why I am using the term dimensionally correct. So now my dear, here you can see each term is dimensionally correct, or at the most I can do one more step. This is written as L power 1 M power 0 T power 0 is equal to L1 M0 T0 L1 M0 T0. According to mathematics, if I take this is 2 times L1 M0 T0. I can do that, na? It is 2 times L1 M0 T0. No issue. Because if I take this as X, so this is equal to, so if this L1 M0 T0 is X, so this L1 M0 T0 is also X. This L1 M0 is also X, because supposition is same. So this is X is equal to X plus X. So this is X is equal to 2X. But my dear, I know that 1x cannot equal to 2x. I know 1x cannot equal to 2x. I understand. But x is equal to x. So here this 1 and 2 is number. And we are not interested in number because numbers are dimensionless. So here what we can say at the most, I am writing that. So here after getting, suppose तुमने ये step किया भी, sir L1 M0 T0 is equal to 2 times L1 M0 T0. So again there is one step. Since 2 is a number, hence it is, come on beta, dimensionless. Therefore, now what will be happen? L1 M0 T0 is equal to L1 M0 T0. I avoided this 2. As I avoided this half here, I can avoid the 2 here. You can come with this step, no issue. Or you can say here only, sir, each term of LHS and RHS are same. Hence the equation is dimensionally correct. Or if you wanted to exceed one step, do one step, exceed one step, no issue. This is L1 M0 T0 is 2 times, because one of the student of our batch has asked me this question, sir, it can be twice. Yes, it can be twice L1 M0 T0. But my dear, what is the point here? That 2 is a number. So if I avoid this number, the dimension of LHS and dimension of RHS become equal. And I have to avoid because 2 is a number, I am doing the dimension topic. Hence, I will say here, therefore, LH, left hand side dimension, I can write this way, LHS dimension is equal to RHS, that is RHS dimension. Am I clear? Thus, the given equation is dimensionally correct, but not, I am writing this line, I am specifying this, but not mathematically. Why not mathematically? Sir, I have given this example, 1x cannot equal to 2x. This is say x. So of course this is also x, because if I take L1 M0 is x. So this L1 M0 T0 is also x. So what equation I will get? 1x, here this is 1. So 1x is equal to 2x. Hey, how can it possible? 1x cannot equal to 2x. So mathematically I am not proving it. What is my point? Sir, x and x are equal, na? X is a dimension, and here also the x is a dimension. Dimensions are equals. So we are working on dimensions of LHS and RHS. So that's what I have written. Thus given equation is dimensionally correct, but not mathematically. Because mathematically I cannot say 1 time of L1 M0 T0 is equal to 2 times of L1 M0 T0. But my dear, L1 M0 T0 and L1 M0 T0 are the dimension, they are equal. And that is the principle of homogeneity. That's what the principles say. Each or every term of LHS and RHS has same dimension. They are not worried about whether they are equalized with the same number. Because we are doing dimensionally correct equation, not for mathematically to see the equation is correct or not. So that's all, my dear. This is one example I have given. Now I will take more examples. So I will clean it out, pause your video, note it down, and then we will go for the next question. Well, now look at the next example on the basis of principle of homogeneity. That the question is V is equal to under root 2 Gm by R. Here, my dear, you should know which quantity is what. Here V is velocity, G is gravitational, because now you know everything. See, that's what I have, that's the reason why I have given so many physical quantity ka dimension first to note down. what is the dimension, how we calculate the dimension of these quantity, and then we have to go for the numerical of such type. So this is gravitational constant, G is gravitational constant, M is mass of earth can be taken, and R is the radius of earth. See, that you should know first, then only you can proceed. So now my dear, here what is my suggestion? I start doing the thing as the question is. Here I will write left hand side, and this I will put it as equation number 1. So on left hand side it is velocity. So dimension of velocity you all know, this is L1 m0 t minus 1. That's all, left hand side over. I will put this as equation number 2. Please put the equation and do it in the right manner. So I have calculated the dimension of velocity, I have written here. Now my dear, on the right hand side there is only one term. In earlier example there was 2 terms, I have taken one by one. But sometimes the equation has LHS also has one term and RHS also has one term. Don't see these so many physical quantity and count them as a term. Term are described only by plus sign and minus sign. Please, now you are in class 11, you are understanding so much. Right? So on the RHS side also there is one and only one term. So here I will write RHS, and in RHS here it is given under root 2 Gm by R. That can be written as 2 Gm upon R whole power half. I hope it is clear, because in dimension any question is like under root. Please you make that under root conversion in 1 by 2. That is half. Everybody know, all maths rule. Now next step my dear, here I will write, since 2 is a number, hence it is dimensionless. So first I will remove the 2 by saying this statement that 2 is a number. So we no need to find its dimension. So now for dimension, the dimension of this is Gm by R. See, this is the way. Here I have written curl bracket and I have converted this equation power half. But when I go to carry out its actual dimension, I will put it in box. So this is Gm by R whole power half ka dimension I supposed to find. So this is dimension of G. Dimension of G I need. So this is, I can write this way. Now my dear, here there is one request. Suppose I don't know what is the dimension of G. For example, I am doing, and I don't know what is the dimension of G. So here I will make rough. And on this side, first I will calculate. Right now I am doing this video and I don't know the dimension of G. Now what to do? In the exam also, because it is not possible to learn every dimension. So now first I will calculate dimension of G here. Because dimension for G is, formula is Fr square upon M square. This is the formula for dimension of G. So dimension of G will be nothing but L1 M1 T minus 2, that is for F, multiply by L2 divided by M square, that is M power 2. I hope, please look my video. I have given dimension for gravitational constant and this is the formula to calculate it. Fr square upon M square is the formula to calculate dimension of G. So dimension of G, my dear, is equal to what? Sir, it is L1 and L2 become L3, and this is M1 and this is M2 will go up, become M minus 1, and this is T minus 2. So now I calculated the dimension of G and that I will substitute here. So this is L power 1, M power 1, L power 3, M power minus 1, T power minus 2 into, this is the dimension of G, into, here it is M, So here I will write into, this is m power 1. So you can do that way. This is I have written dimension of G. This is I have written dimension of mass divided by dimension of R is L power 1. And this whole dimension is divided power half. See the method. What I did? I have written dimension of G here. I have written dimension of M here. I have written dimension of R here. That is radius means length. And then whole thing. Here is the entire big box and whole power half. So now what is the answer for this? This is L power 3 and this is L power 1. You can see this is 3 minus 1 will become L power 2. This is M minus 1 and this is M power 1 become M power 0. And this is T power minus 2. And then this is whole power half. Please take care. This will be G M by R whole power half ka dimension. You can see carefully. So now this is G M divided by R whole power half. Whole power half is equal to, now let's solve. This is L power 2 and this into 1 by 2. This is your first time and therefore I am doing each and every step. This is 2 into 1 by 2. This is M power 0 into 1 by 2. And this is T power minus 2 into 1 by 2. You can see. So what is the answer for G M by R whole power half ka dimension is, sir? The dimension of G M by R whole power half dimension is L power 1 because 2 and 2 cancel. So it is L power 1. 0 into half is 0 only. And T power minus 2 into half will be minus 1. This I will put it as equation number 3. So I substituted 1, I substituted 2 and I substituted 3. Now there is nothing left. I have found every dimensions. So this is rough work. Why I did rough work? Because sir, in this dimension, capital G is gravitational constant and this dimension I say in the exam, I don't know orally. So I have calculated first in rough and then I have substituted that answer in place of G. Rest all dimension is orally, which I can do ourselves. Mass ka dimension is oral, R ka dimension was oral. So now my dear, here I will ask, substituting 2 and 3 in 1. So when I substitute 2 and 3 in 1, here in 1, left hand side is V and dimension of V is L1 M0 T minus 1. This is 2 is substituted in 1 in place of V. V के जगह पे मैंने equation 2 substitute किया, ये मिल गया. Is equal to 2 I already written here. 2 is a dimension. This is dimensionless. All that. So now what is the dimension of Gm by R whole power half? The Gm by divided by R whole power half is L1 M0 T minus 1. So here also I will write L1 M0 T minus 1. I hope it is clear. So now my dear, here I can write left hand side dimension, LHS dimension is equal to RHS dimension. Okay. In some of the book it is given this 2 is a number I am writing separately, right? I am writing separately and I am removing it out. In some of the book they keep writing 2 here, 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 here. They keep writing. They keep writing the 2. And they don't write this statement. But my dear, this statement is very important. Because here when I write 2, but here I don't take 2. On the right side you can see. यहाँ 2 लिखा है. But यहाँ पे मैंने कहीं 2 नहीं लिखा है. Why? Because 2 is eliminated by saying it is a number, it is dimensionless. So even if you keep writing this 2, please don't take the dimension of 2 on the right side. Take the dimension of the physical quantity. No issue writing 2 gm by r, 2 gm by r, 2 gm by r, because it is 2 gm by r. I understand I cannot remove this 2 from here. But my dear, since we are finding dimension of the physical quantity, not the number. Number is dimensionless. So if I keep 2 in the equation, no issue. But while finding the dimension, don't write this 2. Because you already stated that 2 is a number, it is dimensionless. So you can do that way. You can write this way. No issue. But here there should not be 2, because I have written one instruction that while taking the dimension, I will not write 2. Wherever it is given in term that 2 is there, but I have stated that 2 is a number, it is dimensionless. So while finding out the dimension, I will remove the 2 here, and I will not write the 2, I will just write the dimensions of the physical quantity. So I hope you are clear, and here I can write the given equation. The given equation is dimensionally correct. Please keep writing this. Why we are writing this? Because mathematically they are not correct. We have not taken this 2 on this side. We have just found the dimensions of the quantities. And we have removed 2. Though the 2 is written here, that's what I am saying. कि लिखने में कोई बुराई नहीं है, आप लिखते चले जाओ 2, 2, 2, 2, no issues. In earlier example, half at square, you keep writing half at square, no issues. But don't take the dimension of half. That is a number, it is dimensionless. Okay, so I hope it is clear you all, my dear. So now I will upload next video में again the principle of homogeneity, but the variety of different questions. So please you go through it, each and every questions given by me from this side, so that you can write your exam answers very well. Definitely we will ask you the exam answers questions from these examples only. Thank you very much, and wait for the second video.